Okay, last example on Chapter B. The radius of this circle is 10 centimeters. Find the length of a 45-degree arc in the area of a 45-degree sector. Let me first of all focus on some vocabulary here so we know what things are. If it says arc, it's talking about the edge of the circle. Okay? Arcs have length. They're going to be some length, like 3 feet, or in this case meters, 3 centimeters, 3 centimeters. All right, and I don't know if it's 3 centimeters, but I'm just saying that's how they are. And then it says the area of a 45-degree sector, that is the pi. Piece of pi is a sector. So the arc is the edge, the sector is the piece of pi. Arcs have length, sectors have area. All right? Now, both of these are portions of a circle, which is nice because the formula is very straightforward if you think about it that way. What is the circumference formula for a circle? 2 pi r. Right? Or pi d, depending on what we're dealing with. In this case, we've got a radius, so 2 pi r is one we would use. So if I want to know how far it was from here all the way around the circle back to there, I would do 2 pi r to find the entire length of the circle, right? How many degrees are in a circle? 360. How many degrees are we going? 45. So we're going part of the way around the circle. Fractionally, we're going exactly 45 360ths of the circumference of the circle. Okay? As far as the formula is concerned, this right here would represent a variable. In this case, our variable value is 45, but whatever angle they give you, that's what angle you put there, over 360. Because again, anytime you're dealing with the arc length, you're dealing with just a portion of the whole area of the circle, or the whole circumference of the circle. So how much you're going divided by a whole circle times the whole circle's circumference gets you the length of the arc. So in this case, the radius is 10 centimeters, so our circumference, the arc length here is going to be 45 360ths times 2 times pi times 10. 62.8 is what this would be, but then times that. All right, so once you get all your numbers figured out for your formula, again, formulas are all about you use the right formula, you substitute the correct numbers, and then you evaluate it correctly. The way your calculator works for this, the way I would type it in, is I would type in 45 times 2 times, divided by, times 3.14 times 10, all the top stuff, this times this times this times this. Once I've multiplied everything, then divided by 360 equals. And you see the answer is 7.85. And that's how you find arc length. Circumference of the whole circle times what fractional part of the circle you have. Okay. With that in mind, anybody have an idea of how we might find the area of the sector? Caitlin?
45 over 360 times the area.
You find the area of the whole circle, and you simply take the portion of the circle you're dealing with. Area of the whole circle is pi r squared. And we're doing only 45 degrees of the circle, so 45 360ths. Again, for the sake of the formula, this represents a variable value, and this specific problem is 45, but whatever angle they give you, which they will, that's what you put in there. So in the case of this specific problem, 45 over 360 times pi, which is 3.14, times r squared, which is 100. Just like yesterday, or the day before, whichever day I did that. If I can square it in my head, I'm going to square it in my head instead of writing 10 squared. That's one less button I have to press on my calculator. It's all multiplication and division instead of powers. So once again, I've got my entire thing figured out. It's this times this times this divided by that. So 45 times 3.14 times 100 divided by 360 equals. It comes out to 39.25. That's centimeters squared. All right, now notice I found two things, right? Arc length and area. L, A. L for length, A for area. Identify answers when there's more than one answer. Give me an identification of what they are so I know that you know what they are, that you're making a distinction between these two things. But again, arc length, sector area, it's the same as circumference and area. You simply have this extra fraction you got to deal with. What you have divided by 360 every single time.